Okay, gradiens, ons kom nou by seker die belangrikste werk wat ons al hierdie jaar gedoen het, want alles vorentoe in chemie gaan bou op die mol konsep. So this is new, and it's part of almost like the language of chemistry that you guys have to learn. So if today is a bit confusing, don't be alarmed by that. I'm going to do more examples than probably necessary, but you guys need to start understanding the mole concept, and I'll explain to you exactly why it is so important. Okay, so we've seen the SI unit before in the work that we do. Okay, so onthou 'n SI eenheid is die standaard eenheid waarin iets gemeet word. So we say for mass we measure it in kilograms, and for distance we measure it in meter. En dit is so oral oor die wêreld. So if you measure 1 meter here, it'll be the same if you measure it in the Alps or if you measure it in London. It doesn't matter where you measure 1 meter, it'll be the same everywhere. And when we are doing calculations, we have a SI unit for everything that we substitute into the calculation, meaning that if I have a formula and I need to put a distance in there, I'm going to put it in meters, and someone else is also going to put it in meters. They're not going to put it in kilometers or in millimeters. So die SI eenheid is 'n standaard eenheid wat wêreldwyd gebruik word om iets te meet of te weeg of 'n mate daarvan te kry. Now the problem comes in with the size of an atom or a molecule. So if you make one little dot with your pencil on your page, then that little dot has approximately 10 to the power of 13 carbon atoms in there. Ek het dit vir julle hier uitgeskryf. So net daai een klein stukkie wat basies niks weeg nie, het soveel atome koolstof, which is an insane amount. And then they said they had to come up with a concept to measure something that is so small that we can't observe it with the human eye, maar ons moet nog steeds 'n konsep daarvan kan hê, want ons gebruik chemie oral om ons. Alles om ons is uit atome en molekules gemaak. So we need a way to measure that in some way. So the word mole is derived from the French word mole with an E, and it translates to a massive heap. So they said that we have a massive heap, but it is so small that we can't see it with the eye. En toe kom hulle op met die konsep van mol. So, stay with me guys. Mole is the quantity of matter that you find in 12 grams of carbon-12. So, hulle het 12 gram koolstof 12 gevat, ek sal nou vir julle verduidelik hoekom, en uitgewerk hoeveel koolstofatome daar in daai 12 gram is. And now that is the measurement of mole. So whenever we speak about 1 mole, it is equal to the particles you find in 12 gram of carbon-12, equal to the number of carbon atoms. Okay, kom ons kom gou eers terug by hoekom koolstof 12, and you guys don't need to know this. But there are 2 reasons for using carbon instead of something else. The one is carbon is a solid at room temperature. So it's easy, you put it on a scale and you can measure it. Onthou hierdie het gebeur, wanneer het dit gebeur? In 1811, in die 1800s. Way back. So they didn't have all the measurement tools that we have now. They were working with a much more elementary science back then. Okay, so hulle het koolstof gevat, omdat koolstof is 'n vaste stof en 'n vaste stof is mos maklik om te meet en te weeg. The second reason is just because carbon is cheap. You can't use something like gold or something like silver because it's more expensive. So carbon we get all around us. It's not toxic like mercury, and it's cheap to get around, and you can just weigh it off on a scale. Okay, so hulle het koolstof gevat en hulle het uitgewerk hoeveel partikels is daar in koolstof 12. What am I talking about? I'm talking about carbon 12. You guys remember from grade 8 and grade 9, when we look at the periodic table, up top you have the atomic number, and here you have the relative atomic mass. En hierna gaan ons aangaan na atoommassa toe, dis baie belangrik. So they're talking about carbon-12, meaning that it's carbon that has a relative atomic mass of 12. Dis waar die 12 vandaan kom. Okay, so hulle het gesê 12 gram van koolstof 12 het 6,02 maal 10 tot die mag 23 partikels. So this, when we look at it like that, it doesn't really do it justice. So in your books, they have some examples for you on how big a number that is. I mean, I can write it out now with the zeros, but that won't really give you a proper idea. So op bladsy 273 sê hulle vir jou, en julle hoef obviously nie hierdie te weet nie. Ek wil net hê julle moet begin dink aan wat dit beteken. So hulle sê vir jou, hoe groot is dit? Hulle sê, if there were Avogadro's number of, so daai hoeveelheid, grains of sand that were spread evenly over the state of California, then the sand would be the same height as a 10-story building. Dis nie vir ons so maklik om te verstaan nie, want ons ken nie California nie. Die derde ene maak bietjie meer sin. As ons papier divide, if we divide paper into 1 million equal piles, then those piles would stretch further than the sun. Or if we were to have a computer that can count atoms at a rate of 10 million, 1, 2, 3, 4, 5, 6, 7, 10 million per second. So as ons 'n rekenaar gehad het wat soveel atome per sekonde kon tel, dan sou dit nog steeds daai rekenaar 2 biljoen jaar gevat het om by daai uit te kom. So this is an insane amount of particles, and this should just really reaffirm to you how small an atom is. Met ander woorde, as ek 'n bakkie het en ek sit 12 gram koolstof daarin, dan is daar binne in daai bakkie daai hoeveelheid koolstofatome, which is insane. So you can just, I don't even know if we can start to imagine, but you can just imagine the amount of atoms or molecules that make up your body as you are sitting there. And I hope you feel purpose-driven and you take on the day. Okay, goed, so nou kom ons bietjie by hoe ons daaroor praat uit. So if I have 1 mole of sodium atoms, nie ione nie, net soos wat hy op die periodieke tabel is, natrium atome, then if I have 1 mole of that, it means that I have 6,02 times 10 to the power of 23 atoms of sodium. Okay, goed, onthou ons werk heeltyd met Avogadro se konstante. This one here. Avogadro was 'n wetenskaplike in die 1800s en sadly het hulle eers hierdie aan hom geattribute toegeken na sy dood. Hy weet nie eers nie, maar hy het baie werk gedoen in die veld van chemie en die kwantifisering van chemie. So remember, when we are working with quantitative aspects, it means that we are measuring something. So he spent his life trying to measure chemistry, which is almost impossible because it's so unpredictable. But we are so far from where they were that we can actually look back on their work and study it and then maybe even grow on that. Okay, goed, so 1 mol natrium atome is 6,02 maal 10 tot die mag 23 natrium atome. If you're looking at 1 mole of hydrogen gas molecules, now you have to be careful. This 1 mole refers to whatever it is that we are looking at. So then you have Avogadro's number of those molecules. But let's say I asked you, how many hydrogen atoms do we have? Then it means you have to say, okay, in each of these we have 1, 2 hydrogen atoms, meaning that 1 mole of hydrogen gas, H2 gas, represents this times 2, which gives me 1,204 times 10 to the power of 24 atoms. Goed, as ek dan aangaan en ek sê 1 mol watermolekules, then it means this 1 mole represents that amount of water molecules. Avogadro. But now I can go and I split it up. So I can say in each water molecule, I have 1 oxygen. So I have that amount of oxygen atoms. But I have 2 hydrogen atoms, meaning that that times 2 gives me the amount of hydrogen. As ek nou byvoorbeeld iets gehad het soos SO3, dan sou ek vir die hoeveelheid suurstofatome gemaal het met 3. Goed. And what you guys need to understand here is that all of these are covalent bonds. So when we're talking about them, we call them molecules or we call them atoms when we break them up. Maar as ons nou aangaan en ons werk met Ioniese bindings, soos natriumkloried. Onthou ons het mos nou gesê ioniese bindings is wanneer dit tussen 'n nie-metaal en 'n metaal voorkom. Okay, then we still think in the same way, but we call it something else. So 1 mole of sodium chloride gives me Avogadro's number of those, but we call them formula units now. And the reason why we call them formula units is because we are working with an ionic bond now. Okay, so jy gaan noem hulle formule eenhede, but in that we can split it up into the sodium ions and the chloride ions. So ons gaan sê ek het soveel natrium ione en ek het soveel chloor ione. So when you're working with ionic compounds, make sure you understand you no longer call them you no longer call them molecules or atoms if you break them up, you call them formula units or ions. Okay, graad 10s, ek gaan eers daar stop vir vandag want dit is genoeg om nou aan te herkou. So you guys can go and read through those pages again. And then when I see you guys again on Thursday, I will recap this quickly and we will carry on with new work.